Hey Layla, is my sound working? Let me know. I don't know why I do this every single time. Okay, sweet as. Thank you for that. YouTube, how are we going today? Oh, YouTube is quiet. Is YouTube working? Okay, no, that's good. YouTube's working too. All right, team. So usual today, we're going to be going through level 2 calculus. I think we've got about 5 questions as usual. Congrats on the award. What award? What did I get? Did I get an award that I didn't know about, Entangle? Oh man, I forgot how to say your name. Damn it. Oh, is that? Are you talking about the old one, Entangle? Oh yeah, that was a while back. I was just putting that back up because no, not you, Entangle. I'm talking about the person above you. I think it's Eilish. I think. All right, so let's get kicked off today. So we're gonna be Elise. Yeah, Elise. Damn it, I was so close. So we've got what do we got? We've got a couple of achieved questions, and then we've got just getting all my resources ready. Hold, people, hold. Looks like it's oh no, I'm wrong. 2 merit, 1 achieved, and 2 excellence questions today by the looks of it. Yeah. All right, so let's get started. This is going to be our first question here, which is sketch the gradient function. Now, I know that you guys can't actually see this very clearly, so I'm just going to write the points down. 2, 4. So those are all that, whatever the x values are. Yeah, you too, Entangle. And we'll go from there. So I'm going to give you folks maybe a couple of minutes to try and answer this. Praj, this is level 2 calculus. Does it not say in TikTok? I thought I actually put that as level 2 calculus. Yeah, there is a live info there. There we go. Jaeger, yes, you are able to watch it later. It'll be on YouTube. All of the live streams that I do get saved on YouTube. Hi, Nimisha and Shanvi and T4J. It was a one shot. I'm still in pain from Friday's dance. Jackson, yes, it is level 2 calculus. I haven't done TAFE in a long time. All these OJC people are here. What are they all doing here? Guys, go to bed. It's like past your bedtime. All right, team, I'm going to go through this question here now. Unfortunately, I have not drawn this very well because, but I guess we're going to try our best because I try to do the screenshot as best as I can. So what we've got to do is I always look at the turning points. So the turning point is right here. And usually these grids are drawn right underneath each other. So you should kind of just be able to, just draw a straight line wherever the turning point is. And I usually have like a ruler, but I don't know where my rulers have gone here. So just going to roughly do this here so you can kind of get an idea. Now, this is actually a negative x cubed graph. Now, I don't exactly know what the full details is. Like, I mean, I know it's a cubic shaped graph. That's all I know. And when I differentiate it, because I know I'm asked to find I've been asked for the graph of the gradient function. So if it's negative x cubed, when I differentiate it, I'm going to get negative 3x squared. So the shape of the gradient function is going to look like this. That much I know. So all I got to do is I've basically got to just figure out, just literally just put that shape in there, and you're pretty much good to go for it. Because if you look at it, these two little blue points are the turning points where the gradient is actually equal to 0. So that means as long as this parabola looks something like this, you are pretty much good to go for that. Now, I just want to double check this, because last year, this was from 2024 question 2 paper. And as long as this part here, it's like, there's somewhere, I can't really say where it is, but it's kind of somewhere in the middle there. You can, and I kind of botched it a little bit here. But as long as that shape is there, you're pretty much good to go for this question. So what do they look for? They look for whether this point is correct, this point is correct, and if your shape is actually correct. And if all that's done, then you usually end up getting a merit for it. So it's pretty nice to get a merit. Nikki, yeah, that's a good point. I should have actually thought about that before I put those numbers in. But initially when I looked at the graph, I was like, oh, you guys would need this number, so I'm just going to throw it in there. But hey, look, if you are finding this a little bit tricky, and there's always going to be a question like this for calculus, right? They're always going to ask you guys to draw either the gradient function or reverse it, where they give you a gradient function and then they ask you to find the original function. So it's going to be there one way or the other way. So it's really quite useful for you guys. It'll be useful for you guys to actually get a hang of this. Jolyn, yes. So I always do like, see, like if you think about it like this, right? You've got x, which is either a straight line like this or like that. Then you've got x squared, which looks like this, or negative x squared look like this. X cubed looks like this. The negative version looks like that. And then x to the power of 4. Now, last couple of years ago, they put x to the power of 4. And that's because the graph actually looks like almost like a W, and the minus version looks like an M. So Jolyn, as long as you get the rough shape and rough, like the x to the power of whatever, and as long as you differentiate it, then you're pretty much good to go. And you don't need to be accurate. Like, look, I just used minus x cubed. I know that's not minus x cubed, but it starts off with minus x cubed. Bob the Builder, we'll get to that question. I think we've got a similar question like that with context and about 2 questions down. The W to the, like, I think x to the power of 4 was maybe like a couple of years ago. Why I don't think it matters how high your turning point is. The parts that they will look for is whether these points are lining up with the turning points. The shape is another big one that they look at. If that's not it, then it doesn't actually work out. Suhail, this is calc. Welcome back, Sterling. Let me know if there's any other questions in this one, folks. If not, we can actually head off to the next question. And I think Bob will be looking at a similar question like that. Yeah. So I think what does it mean for the derived function? Nikki, to answer your question with the concave up and concave down, any kind of shape like when I look at like the U shape kind of thing, I put that as concave up. So if you look at it, wherever there's a U, that's like concave up. That's how I look at it. For me, easy to remember. Jimmy, the x-intercepts at the bottom gradient is where the gradient is actually equal to 0. So because remember, we're drawing the gradient function in the bottom graph. So those two little green highlighted parts, actually, no, I just figured this out. So because this is a turning point, out here, that's going to be where the gradient function is going to be crossing the x-axis. So again, because the gradient function is turning point is there, it's going to cross over there, and turning point is there, it's going to cross over there. All right, Bob, if that's the case, then you would need to double differentiate, and I'll talk to you later about this. Maya, yes, we've got 2, 2, 1. Nikki, yeah, I suck at that concave up and concave down, so that's the easiest way I remember it. Oh, sorry, hang on. I haven't actually attached the new playlist. Give me a second. I thought I had actually added it, but I'll tell you what. While I fix that, I might go to the next question. Is that all right? Because if we go to the next question, yeah, we'll go through the next question and then we'll go from there, right? I'll put up the schedule very shortly, folks, because I know I printed it this morning, but I forgot to actually add it to the live. So you guys try this question, and then we'll go through it very shortly. This is surprisingly a merit question. I was really surprised by this. And I'll give you folks maybe about 2 more minutes to kind of work through it, yeah? And source, image, where are you? Image file? There we go. Yeah, Alan's on the money there. What is T4J? Uh, 702. Yeah, I thought it was achieved as well, but I was really surprised last year when they gave it as a merit. I guess they might have actually changed something else. But yeah, I couldn't figure out why. No worries, Kieran. You're welcome. All right, so let's go through the second question here, folks. I'm just going to grab the schedule. All right, so if we want to find equation of the tangent to the graph, what we're going to need to know is we need a gradient. We also need the point. We've got the point here. The point is f of 1 is equal to -3. What we need to figure out is what is f dash of 1, because that's going to be the gradient. And then we just put equation of the line to actually solve that. So I'm going to work out g dash of x first. So g dash of x is equal to 3x squared minus 12x. And then I'm going to put g dash of 1, because this is going to give me the gradient when x equals to 1. So that's going to be 3 times 1 squared minus 12. And so I'm going to get g dash of 1 is equal to -9. Give me a second. I just want to double check something, because this again feels So easy, but yeah, this was given a merit as well last year. So now that we have the gradient, we put the equation of a straight line, which is y minus y1 equals m times x minus x1. And these are the points. So remember, the y1 is right there, which is -3. The x1 is equal to 1. And finally, the gradient, which is m, that's actually -9. So we've got y minus -3 equals -9 times x minus 1. So we've got y plus 3 minus 9x. I feel like I'm making a mistake somewhere here. Plus 9, and then I've got y is equal to -9x plus 9 minus 3, and that should give me y is equal to -9x plus 6. Right, team, so I'm going to put some line numbers as usual. Let me know if there's any particular line that you do not understand, and we'll actually go from there. How'd you guys get the 4? There's a couple of you guys that got 9x plus 4. Jimmy, I'm not sure what kind of question there is. How many kinds of excellence topics are there? Like, Harry, yes, they do give this the equation in line 6 in your formula sheet. So I think that's one of the they give you that and a few other formulas as well. It's all right, Nikki. We all make that mistake. Oh, no worries, Crabman. You're welcome. Since 2 weeks ago when I got told that I need to do it. 702, yeah, like a bacteria one, but I think instead of bacteria, ChatGPT gave me rabbit populations, so. Optimization is another one, Jimmy. And plus also they do the one with graphs. I think today's last question is on graphs and area. So we'll be doing that one at the end today. So we've only got 5 questions. We've done 2 questions so far. Kieran, yeah, I was all right at it. I was more good at stats than calc, actually. Let me know if you have any other questions, people. Otherwise, we'll actually jump on to the next question. This is level 2 calculus. Uh, 702, I think, I don't know, I think I gave the review at the end of the calculus paper. Like right at the end of that video. So I was surprised when I found out that this one was actually a merit, because if you do this, wasn't achieved, and then this part here was a merit, which I thought was actually very generous to get a merit. Alan, yes, the 15-hour playlists cover everything. So, and I think calculus is a 10-hour playlist, and I think someone told me that if you watch it in double speed, you can finish it in 7.5 hours. The whole, well, 7.5 hours for algebra and then 5 hours for calculus. Scott, funny you should actually ask this, Scott. Is this the 9709 paper you're talking about, Scott? Hey, Jack, I looked through the distributions paper, man. Like, I can do the calculations part, but I suck at the assumptions part. And I got no idea how to do triangular and that other one, the uniform one. Looks like we're good with this question. And I might just put the next question up while I wait for a response from Scott. Don't let me down, Scott. Don't let me down. All right, here we go, team. Another next question here. This is an achieved question. And I'm going to give you like 90 seconds. So 8:22, I'll go through the question. Hey Scott, I'm not gonna lie. I think you guys got your exam on October 6th, if I'm correct. I could be wrong, but I was literally spent about 2 or 3 hours last night looking through some papers. Um, I might, like, I know I will. It's not a might. I will definitely do those papers at some point before, like at the holidays, maybe the first week of holidays. So I might do them early morning and have them out, Scott. I didn't realize there were 16 papers. I went through there was like 16 or 17 papers to go through. Harry, this is level 2 calculus, kind of parallel questions from last year's exam. Maybe I need to put like a title there that says, yeah, maybe I will. Right at the bottom there somewhere. You got minus 28. All right, let's have a look through. I think we can go through this question. Yeah, okay. All right, let's go through this. Harry, this is level 2 calc, parallel 24 exam. Yeah, pretty much, Jaden. I think you guys are on the money there. Okay, let's have a look at this. So what they're asking is, what is the rate at which the rabbit population is changing on day 8? Basically, they're just asking for R-8. That's all. So we're going to do R- of t first. And R-t is going to be 3t squared minus 90t plus 500. Then we're going to put R- of 8 is equal to 3 times 8 squared minus 90 times 8 plus 500. I think that looks all right. Let's go into the calculator. So what do we got? Run menu. Yep, run menu. And then we've got 3 times 64 minus 720 plus 500. And that's going to give me negative 28. Yeah, that's pretty much it for this question, folks. And then this is going to be an achieved question. I think most of you guys got that. Let me know if you have any questions on this. Harry is sticky. What I would recommend is go watch the 15-hour playlist on YouTube for algebra first. Once you finish that, then go and watch all the live tutorials. Once you finish that, then go and watch the walkthroughs. I reckon you should get like an easy 18 or 19 after that. And if you're lucky, you might get that excellence question down. I reckon it is triple question mark. Nikki, you're killing me with your silly mistakes, mate, because let's hope you're not doing that for the final exam, Jimmy, like, look, most of the time, this is calculus paper, right? They're never going to ask you to just ask you for the y value and be done with it. They will always ask you to differentiate and find out what's happening with the gradient and so on. So whenever it has like a r dash, that means you're looking for the gradient itself. When you have just r by itself, that means you're just looking for the value itself. This is a rate, so that's what you need to remember. Harry, you've got like 2 months left for the exams, mate. You've got plenty of time. Well, this is kind of rate of change, Alan. Like, I mean, if you think about it like this, we could write this as dr dt at t is equal to 8 is negative 28. So, Yair Betsalel, yeah, I can hear you. If you know what I do, I basically do 2 achieves, a couple of merits, and a couple of excellence. So you gotta be a little bit patient, my friend. Let me know if you guys are good with this, and then we can go to the next question. Amber, I think I'm gonna do level 1 always on Tuesdays. That's when I'm hoping to do level 1. All right, so there's a follow-up question for this one. Now, sometimes they might actually say to you, hey, like, what does this actually mean? When you see negative 28, you can just say it's decreasing by 28 rabbits per day. But yeah, but that's pretty much it. And then let's go to the next part of this question. All right. This one is an excellence question, folks, and I'm going to give you a bit of time to actually work on it. So maybe about 3 to 4 minutes I will give you, and then I will go through the answer at 8:30. Now, if you're unsure of how to start this question, differentiate and kind of work through the question slowly after that, all right? Because it kind of tells you, like, when is the population at the max. So that's your clue right there. Differentiate, put it equal to 0, find the points. That's your standard bread and butter kind of. Anytime you see these word questions with like one equation and then they're asking you for something, just differentiate, put it equal to 0, and you almost will get a merit for that. Jackson Holiday, 100% it's possible. I'm good, Casson, I'm good. Ames, don't stress too much. I mean, I know it would have been sting to get that, but you start the work right now, and I can tell you, like, you probably will get it quite easily. You should be aiming for at least 17, 18 in a paper. Nah, Harry, I'm telling you right now, you got plenty of time, mate. You got plenty of time to get through this. Scott, yeah, I saw that. Like, I was gonna do the pure one. What do you mean? There's 3 pure. Like, I went through Papa Cambridge and I got the 9709. Is that the only one, or are there more numbers? Now I figured out the variance, Scott. But how come there's no YouTube videos of the Cambridge exams on YouTube? Like, I look for it and there's hardly any. I thought it would be like heaps. Yeah, that was a while back, Casson. That was a while back. Still hoping to kind of work something there. So remember, guys, as I said to you, try and kind of put it equal to, differentiate, put it equal to 0, and then give it a go. Amora, what year level are you, Amora? No, 30 seconds, team, and then I'll go through the answer at 30 seconds. So Scott, if I do 9709, is that just pure? Let me just find it. Oh, this pure mathematics 1. How do I find pure mathematics 2? Variant 2. What? Man, there's so many different questions. Mathematics 9-7. Ah. What? Wait. I'm gonna get sorry, before I do this question, I just want to double check. So Scott, this is what I was looking at. I was looking at 9709, but is that pure mathematics 1? And then where do you get pure mathematics 2 and 3? Because when I looked at these numbers, these are like old papers. And then I couldn't find statistics here. Is Tamil, but not statistics. Yeah, this is all I have, man. But yeah, that's what I'm going to be using to make those videos. Oh, they're all in the 9701 code. Okay. So that means when I'm looking at a paper like this, all the questions, these are the questions you guys will be doing. So that's like all pure 1, pure 2. Oh, paper 1 equals to pure 1. So then if paper 1 is pure 1, is paper, where is it? Where did it go? Let's go May. Oh, paper 2. Right. Is this pure maths 2? Okay. I understand now. Right. Okay. That's enough for me. That's enough learning for today. All right, Scott, I got it, man. All right, I'll start making those videos at some time soon, yeah? I've got this probability video to make. But once I've finished making that, I will actually come back to your stuff and have a look. But answer me this, how come there's not enough videos of it already on YouTube? Like, why isn't there any resources there for you guys? Because I thought Cambridge was like global, so surely you would have that, right? But anyway, I'll come back to you, Scott, but I've just got to get through this. All right, team. So basically what we're going to do is we're going to differentiate first. So when we differentiate r dash of t, we're going to get, I think we already did this, 3t squared minus 90t plus 500. Now, what we need to do is we need to figure out what the max and min here is. Because at maximum, that's when the food is all used up. Population at a minimum, that's to the day rangers added more food. So that's when the population is at a minimum. So we need to figure out those two turning points. Now, remember, we just need to figure out, put this equal to 0. So when we put r dash t equals to 0 for max and minimum, or you can actually say for turning points as well. Saber, this is level 2. So we've got 0 equals 3t squared minus 90t plus 500. Now remember that when you are in calculus, like you can actually just use the graphics calculator straight away without having to show any kind of working. So especially for quadratics. So you can just go into equation, go into polynomial, degree 2, and we're going to put in 3 minus 90, 500. And what we're going to get is our two values. Now, we've got t equals to, I'm going to go with double decimals, like maybe 2. Yeah, 7.36. And then 22.63. Now, once I have these two t values, I could substitute it in the original r value, r of t, to figure out what the population was at that time. So when t is equal to 7.36, r of 7.36 equals 7.36 cubed minus 45 times 7.36 squared plus 500 times 7.36 plus 2000. And I've just got to chuck this in the calculator, so I'm going to put in 7.36 to the power of 3 minus 45 times 7.36 squared. Putting all of that in that one line. Minus 45 times 7.36 squared plus 500 times 7.36 plus 2000. So that's going to give me 3641. So now remember, R is a whole value, so I'm going to say roughly 3641 because it's a whole number that I got to do. And then I got to repeat the process for T is equal to 22.63. So R of 22.63 equals to 22.63 cubed minus 45 times 22.63 squared plus 500 times 22.63 plus 2000. Let's see if I can try and do this in one shot. I don't know if it's going to work, but let me try anyway. Oh, it does. 22.63. Oh. Whoa, I feel like I've done something wrong here. What did I do wrong? Minus 40, man, not 4. 45, sorry. Not. That's better. So R is approximately 1858. So the question's actually asking, calculate the difference in the rabbit population from literally from the max to the min. So we could just go 3641, take away 1858, 3641, because that's the maximum. So 3641, take away 1858. That's going to give me approximately 1783 rabbits. All right, team. So as usual, I'm going to put a few line numbers and let me know if you have any questions. By the way, this was actually categorized as an excellence question last year. Jimmy, they can mix it up. I can never really tell. Salis, it's not a bad idea to invest in one. Zoe, no, I didn't use the discriminant formula. When you got the two values for T, did you? No, I used the quadratic formula, sorry, not the discriminant. Because I used the quadratic formula because I put the gradient is equal to 0, Zoe. Yes, Layla, this is calculus at level 2. Is there a way to get to line 4 without graphics calculator? Yes, Harry, that is called the quadratic formula. So if you don't have a graphics calculator, then yes, you've got to go down the quadratic formula route. Now, I don't think you can factorize it. You've got to use quadratic formula. Alex, in this particular question, we didn't need to double differentiate because what happens was when we got the two turning points, we knew that one of them was going to be max and one of them was going to be minimum. And as long as we subtracted the actual values, then that's what the question was actually asking. It doesn't ask you anywhere to prove something is a maximum or minimum. Jimmy, for calculus, you can just do it directly in your graphics calculator. Yeah, see, this is why I got frustrated with last year's calc paper to a degree, because I felt that some of the questions were like were pretty much too easy. Like this was not an excellence level question. I felt this was more a merit, but that's what they did. Jolin, in this particular case, because I was looking at rabbits and I just wanted to go under rather than going up, because you know, theoretically I can only have 3,000, I think it was 1858.9, while it would have been, you know, rounding sense, you'd probably go to 1859. I chose to go 1858 because I don't like to add an imaginary 0.1 of a rabbit, right? Now you can double differentiate, but you wouldn't need to double differentiate in this case. Only when they ask you, right? Like they sometimes they'll say justify this is a maximum or a minimum. Yeah, Alex, the double differentiation is for, generally it's for justification. They'll say prove that this is a maximum or something like that. Yeah, Harry, I was surprised when this was awarded excellence last year. All right, let me know if you have any other questions, folks. Otherwise, we've got one more question for the night and then we should be done. Yeah, 1782. It's an approximate answer there, Roro. So even if you got 1782, that's fine. Throw an emoji if you're ready to move on, folks. Next question is our last question for the night. It's very similar to the 2024 one. Kesson, yeah, look, I'll show you what happens if you double differentiate, right? Like sometimes you want to know. If we double differentiate, r double dash of t is equal to 6t minus 90. Then all you can do at this point is substitute 7.36 and 22.36. And I'll show you guys what it looks like. So 7.36 and 22.63. So here, r double dash of 7.36 is 6 times 7.36 minus 90. 6 times 7.36 times 90. Damn it. Minus 90. So that's going to give me negative 45.84. And then r double dash of 22.63 is 6 times 22.63 minus 90. And that's a positive value, which is 45.78. So here what we can say is, since r double dash of 7.36 is less than 0, this would be a max. R double dash of 22.63 is a positive number, therefore it's a minimum. Now if you look at it, when it's 7.36, it is a max because the actual R value is actually higher compared to the 22.63, which is actually 1858. So that's actually telling us that 7.36 is when the max happens and 22.63 is where the minimum happens. Nikki, it's always the opposite way. So if it's negative, it's max. It's positive, it's minimum. That never changes. And that's something that you'll use at level 3 as well. So this double differentiation part is just when they ask you guys to prove it. And double differentiation is way more easier because it's like you just have to show that little r double dash is less than 0 and it's max, r double dash is greater than 0 for min, and you're pretty much good to go. All right, folks, we're going to go to the next question, and that's going to be when there's a positive number, it's a smiley face for a positive parabola. So the turning point is, yes, that's correct, Alan. You are correct there. That's a slightly different variation, Alex. And I don't think we'll have time to do that question today, but I have done a lot of tutorials on that before. So now this question here, I got to put this here. The graph is going to look like this. Sorry, because ChatGPT generated it, I couldn't, like the image was just weird when it came out, but the graph actually looks like this. X, 3x, and yeah, this is definitely an excellence question, Zoe. Yeah, I was looking through it yesterday, Scott, and I was just like, if somebody else came and asked me the same thing as you did, and I was like, oh, do I do this? And then I thought, okay, let me just have a look on YouTube just to see what other people have been doing, and I could hardly find any. I mean, there was a few, but like they were all in like less than like 1,000 or like 2,000 views, and I was like, what is happening here? All right, team. So here comes the last one for today. Very similar to last year's excellence question. Give it a go, and I'll give you folks like maybe about 4 minutes, and I will go through the answer after that. And I think if you guys look at this question is really important, because right at the end they say use calculus to find the maximum possible area of the trapezium. So this is something where you have to actually show that the area that you found is a maximum. Lucas, is that trapezium rule? That's for integration that we're looking at, right? Yeah, I guess you could do that. Trapezium rule. God, it's so frustrating, trapezium rule. I cannot believe you're going to use trapezium rule for this. Actually, come to think of it, Lucas, I think you've got the, like, it just hit me what you're trying to say. So it'll be between 3x and x. Would it work? Lucas, let me know if it actually works. Try it out. Kevin, I'm sorry, mate. I mean, like, you're trying to learn like a big topic. I hope you had started earlier than this. All right, Scott. You know what? I'll take the challenge on. Even though I struggle with distributions, I think Cambridge distributions and probability might be slightly different. I get a feeling, but as long as I think they come up with the answers anyway. So, wait, how do you know which one? Paper 2, paper 4, paper 5, and paper 6. Right. So, hey Scott, is paper 4 and 5 statistics? Just want to check that. Oh no, paper 4 is mechanics. Oh hell no, I can't do that. No, that's way out of my league. Must be paper 5. Probability and stats. Normal distribution. Oh, yeah. NCR and PR. Oh, yeah. Fair-sided die. Yep. Expected. Oh, back-to-back stem and leaf. What? Stem and leaf? Median interquartile. Can do that. Expected value. Yep. Can do that. And then variance. Yep. Yeah. Could do all of that. Normally distributed. Approximation. Use suitable to find the probability. That's binomial. Or Poisson actually. No, binomial. P of x equals to 2. Without replacement. Are you serious? Scott, I'm just having a look at paper 5. Oh, paper 5 is AS year 12. Damn it. Paper 6 is A2 stats and probability year 13. Is the max area? Let me just have a look. 2560 over 27. There you go, Lucas. Did you use the trapezium rule for it, Lucas? Fascinating. Nice. Very nice. Please, any tip? No, I have no tips for you, unfortunately. I struggle with regular stats, let alone scholarship stats. I'm sorry. All right, team, let's go through this question, and then I'm going to have to just sit and have a conversation with Scott as I try and figure out how to do all of this. I reckon that, oh man, that's crazy. I didn't realize there was that much shortage, Scott. All right, cool. Let's actually do this with calculus. Yes, trapezium rule is part of calculus, but I'm going to ask that Maths Teacher's Facebook page to see whether this trapezium rule can be used for this. Anyway, let's have a look at this. Now, here is function of x, all right? So we know the area of a trapezium is half times a plus b over h. So if we think about it, the height of the trapezium is actually this part right here. That's the height. The a part of the trapezium, that's this part here. And finally, the b part of the trapezium is this pink line here. So what we're going to do is we are literally going to kind of create an equation for that and just find the area equation and then differentiate it, put it equal to 0 and be done and dusted. So first thing we're going to do is the blue line here is 10x minus x squared. What we want to do is we're going to find 2 points. I'm going to call this point here, which is going to be P, and this point here is going to be Q. And if you look at the P value, the x coordinate is x. I need to figure out what the y coordinate is. And for Q, the x coordinate is 3x, and I need to figure out what the y coordinate is. So I'm just going to write this separately here. So P is x and question mark. Now to figure out what the P's y value is, I just need to substitute x wherever, because remember, y is equal to 10x minus x squared. Now if I put x where x is, then your y value is just going to be 10x minus x squared. So that means the P point is x, 10x minus x squared. As for the Q, I've got 3x and question mark. Now y is equal to 10x minus x squared. So wherever x is, I need to replace it with 3x. And what I'm going to get is 30x minus 9x squared. Without y, is it 3D? Without y, is it 3D? I don't understand, Slytherin. You might need to ask me that question again, Slytherin. So at this point, the blue length is going to be 10x minus x squared, because that's the length of the, how do I say it? That's the y value of, that y value tells you how high the blue line is. Then if you look at the pink one, that is 30x minus 9x squared. So that is the pink line's length there. Oh, Eric, I'm not tired. I'm like, I did a lot today. I've actually done a massive artwork today, which I'll show you guys later. But let me just finish this question first. So now we got to figure out what the green part is. Now the green part is actually 3x take away x. So the green part is actually 2x. So now that we've got all these three components, we can actually write area of the trapezium, because area of the trapezium is half a plus b times h. So if we look at our components here, h is equal to 2x. The a part, I said that was going to be blue, and the pink part, which is going to be b of the trapezium. So I'm going to end up with a half. A is equal to 10x minus x squared plus b, which is 30x minus 9x squared, multiplied by h, which equals to 2x. So what I have is a half 40x minus 10x squared multiplied by 2x. So I can cancel the 2 out, and what I'm left with is just 40x squared minus 10x cubed. So all this is just to set up the equation. I've not actually started differentiating yet. Now I can actually start differentiating this. So a dash is equal to 80x minus 30x squared. And then a dash is equal to 0 for max. Then I'm going to put 0 is equal to 80x minus 30x squared. 0 is equal to x times 80 minus 30x. Therefore, x is equal to 0, or 80 minus 30x equals to 0. Negative 30x equals negative 80. And then x is equal to negative 80 over negative 30, or x is equal to 8 over 3. Now the question is actually asking me calculate the area of the trapezium and find the maximum possible area. So I've got a equals 40x squared minus 10x cubed. So I've got 40 times 8 over 3 squared minus 10 times 8 over 3 cubed, and whatever this is going to be. So I'm just going to do a little shortcut here. So I'm going to go 8 over 3, and then I'm going to go 40 times answer squared minus 10, damn it, minus 10 times answer cubed So that's going to give me an area of 2560 over 27, or 94.8 units squared. Yeah, all good, Jack. I think it's a good little practice to do that. There's always a question like with the area ones in the exams, and as long as you match up the y values, then you're good to go. Now, the last step is we've got to prove that this is a maximum. So I'm going to take a double dash. So taking a double dash is equal to 80 minus 60x. And then a double dash of 8 over 3 is 80 minus 60 times 8 over 3, which equals to, so I've got 80 minus 60 times 8 over 3. That's equal to negative 80. A double dash is less than 0. Therefore, it is max. There's a lot to unpack in this question, folks, so I will put all the line numbers up, and then we can feel free to ask which part you need help with. Entanglement, you can if you want to. You can also leave your answer like that. This is calculus, Sean. Zoe, the reason why I finally figured out this tool, what number was it? Number 12. Right. So the reason I actually put 3x in here is because when x is equal to 3x, I needed to figure out what the y value was. Because when x equals to 3x, if I figure out what the y value is, that is going to give me the height of this trapezium, which is the b value that I needed. Hopefully that helped you, Zoe. 1 to 33, Corbin. It's called a replay. So basically find the linear equation of a and b. Well, yeah, I mean it's not a linear equation. You find the length of a and b, and then you substitute it into the equation. I think it's calculus tomorrow for level 3. Yeah, level 3 differentiation. It's all right, Corbin. I'm sure if you watch the calculus playlist in the holidays, you'll be good to go. Entanglement, we've got two more level 2 probability ones that I need to finish off, and then after that I can finally call it and just do calculus and algebra all the way through. Hey folks, look, that's pretty much it for tonight. Thank you so much for joining. I'm gonna hang around for a few minutes. I don't know if Scott's still there. Also, don't forget this Thursday there is a t-shirt giveaway. It will be on YouTube, so I will stream it on TikTok, but I probably won't have chat enabled on TikTok. So if you do want to join, you've got to jump onto YouTube to join it, because it's just easier for me to manage it from that place. Yeah, and there's a Google form in the playlist, not the playlist, in the stream that you've got to fill up. Just for me to get in touch with you for emails and things like that. So that's all. Algebra level 2 will probably be next week Sunday, because I'm gonna go right through the holidays, guys. I'm just gonna keep working, so you're more than welcome to just join during the holidays. We'll probably keep the same schedule: Sundays and Wednesdays level 2, Mondays and Thursdays level 3, Tuesdays level 1. This is definitely an E question, Jay. No, Scott, no, I'm actually doing all the those videos. I'll probably will do it in the mornings when I get up early in the morning at like 4 or 5 to do those videos. This is for the NCEA tutorials because most of the guys that come here are NCEA. Oh, hang on. Before you guys take off, I've got to show... oh, this no wonder it's seen so dark. It's like wondering what was wrong with my lights. That's better. Do you do stream calculus every week or on exam prep? Jimmy, we're going to stream every week from this point onwards. 4 times speed. Hey, 702, look, you've got it's revision time, right? And I know I try to wrap things up real quickly. But, yeah, so some of them, you know, just make sure you go through the papers more than anything else. Oh, no worries, Jimmy. You're welcome. Oh, can I show you guys what I've been working on? Like, I've worked on 2 pieces today. I finished 2 pieces. My artwork, which is... Oh, yeah, it is there. Okay, give me a second. All right. This was... how much e-credits you on? Hey, Avnish. All right, piece number 1. So, spray painted and stuck together. Piece 1, and I think this is probably one of my best pieces that I've done in a very long time. There's this one here. Look at that. Well, you can't even see it. So, fully three-dimensional kind of idea behind it. Yeah, it was good fun. Yeah, Soda Pop was actually Fridays. Artwork is to Sundays. Bag is still hurting. WDW. Manuela, have a look at the probability playlist. I've got 2 more episodes to finish. And then we should be good to go. Cassin, it hurt because on Friday I was doing Soda Pop. Dancing for Soda Pop. Terrible idea. Nah, I did a couple of I was on the roller for half an hour and then that was good. Things should be all right by tomorrow. It'll be back to normal. Wow, Alpha Particle, what year did I help you? That's crazy. You're working as an engineer and Stealth, what level are you looking at? What year level are you looking at? Well, entanglement, I've been told that half of Auckland Uni's engineering students, they've always used my stuff, and I keep thinking I need to go visit them. Year 12? All right. Let's have a look. Where is it? There you go. Whoa, this is all changed now. For level 2 stealth, go to YouTube, and I've got an algebra playlist, calculus playlist, and probability playlist. And if you finish with that, head down to the revisions, walk through exams, and you should be good to go. Bloody Remedy, I don't know who you are, but if you know the full story, it wasn't my choice, man. I never wanted to leave. Sometimes you just get told, like when you're in an organization, you get told where you got to go, where you got to go. I have thought about it, entanglement, but every time I go down to uni, I just kind of put a post up, and a few people come and say hi. It's always nice. Toby, I would say, what's the hardest? I probably would say, I don't know. It's a mix, man. Like sometimes, just depends on the paper. Remedy, I had to be strict, man, because it's like I didn't want to be strict, but you've got to keep high standards up with people, and every now and then I think I'm too hard on kids, because people are always like, "Oh, you're so different on YouTube," and I'm like, "Yeah, because I don't have to worry about your behavior. I just kind of work on your grades, and that's pretty much it." Like, but at school it's different, right? Because you've got to make sure, like, I never say this on YouTube. I never say, "Hey, you're late." I never say things like, "Hey, get your books out." I never say, "Put your phone away," or "Hey, stop talking to that person and get on with the work." It's the teaching person that I am in real life has to be different. It's unfortunate, Stealth, but it's all right. I mean, you've got the end of year exam, so you're good to go. Kesson, the giveaway is this week, end of term 3. I've put there's a pinned message on our chat there. Yeah, that's what I would do too, WDW. I'd pretty much do the same thing, do one question and let you guys actually work on it. Well, entanglement, this is what I've been talking about, right? Like a lot of kids actually don't know about me, so that's why I'm like, man, I wish kids knew about this stuff early, because a lot of kids that watch through it, they say it's been a huge advantage for them. Kesson, PlayStation at the moment, but I've actually got this. I need to set this up. I've got no idea how to set it up, but because I got to figure out how to connect my tablet to this, and then so my streaming is better. But I didn't realize that I also could put my PlayStation in it. I did not know that. Entanglement, what school are you at? Rotatuna. I was it's so funny. I was I think my principal and the second principal came there last week. No, wait, Rotatuna, that's in Hamilton, right? Yeah, they came over last week, and I was trying to get a ride with them. I was the first person who successfully taught algebra. Ben, it's 2, man. I like conics practice is as internal, man. Like now it's external season. I do entanglement. Like I think next time I'll come down, I'll do a little meet and greet, because we come to I think the last time came to Hamilton Gardens, and we were down in December last year, and oh bugger. Sorry, Jack. I was planning to sort out something in next week, but I realized that the teacher strikes kind of screwed up my timetable. How do you mean, Kesson? Any scary interactions? How do I set this up? Yeah, I'll do that entanglement. I mean, I put stuff up on Instagram a lot because, but I pretty much have like five, I think 4 to 5 socials that I share quite consistently on. Yeah, Stealth. Is that? I'm trying to think. Was he a former HOD of PE? Maybe. I'm just trying to think. I love skiing, man. I haven't done it since 2003 or four. It's been 20 years since I've seen snow. Stealth, the name definitely rings a bell. Thanks, Bloody Remedy. But man, I'm not gonna lie, Remedy. Every time, because I always work at the cave, and every time I walk past, like yeah, there's always good memories down there. But sadly, it had to happen, and home is now Manu. So yes, entanglement. It's called ChatGPT. I'm so terrible at it. I'm finished, Leanna. I'm finished. I'm done. You can catch the replay on YouTube. It's saved there. Random clips. You're welcome. It's not a problem. Scala, what was this for? Was it for level 1 or level 2? Jun, I have started doing the exam papers without calculator as well, just to help out people. One thing I'd say, Jun, is like see if you can borrow from somebody, my friend. It is worth having. Oh, nice, 1.4. Kesson, I'll tell you one thing. I think the number of times I've talked to my wife in the last 1.5 years about walking away from teaching. Like it's just been too many times. It's like it's been hard work. To be honest, the reason why I do what I do in YouTube is because I love to teach, but just the admin and everything that's happening in schools and the workload, it's tiring, man. Like I get so much energy from doing YouTube because I can actually help kids for an hour and I'm happy for the day. And then for the remaining day, I sit there working on my artwork and I'm happy with that. But when I get to like, I love the kids, love working with the kids, but the work behind the kids, that's hard. But even if, like I've always said, even if I leave teaching, I don't think I'd leave YouTube. Many stinks. Who does many, Evangeline? Remedy, no, I don't remember it. I mean, like, there's so many things that happens wrong in the cave that you kind of just go, yep, you just move on, you learn from it, and you go away from it. Rounds, I'm going to try it in holidays for a couple of hours. You're more than welcome to join just to see how I do the calculations, but don't ask me to do any assumptions. That's all I'm going to say. Random, I actually approached them about it, but I got shut down fairly quickly about it. Conquistador, next, I think level 2 is probability next. He's happy we don't get NCEA. No, Frank. Year 3 math in uni was like my worst. Actually, I got lucky with it. Rounds, it'll always be posted on YouTube. TikTok, I need to get 10,000 to put a playlist. 10,000 subs. I think 10,000 followers. I'm on like 5,000. Like, yeah, I don't think that's going to happen anytime soon. Sure, Riri. Bring the calculator over tomorrow and find me in reception. What about NCEA level 2 calco algebra? Is it next year now? Hang on. Yeah, see you, Casson. Ames, go check out the playlist, probability in 10 hours playlist. You'll be fine. Frank, try failing stage 2 paper for, I think, 3 or I don't know, I lost count, man. Why did I left overseas? Because I didn't want to, because the workload got too much. I love teaching NCEA maths, but the workload got too much. Sleeping, Shayan, sleeping. The dog likes to sleep. He's off to sleep. Abhi, where can I find stuff for stats? Snedden, Liz Snedden is the person you want to have a look at on YouTube. She's amazing at stats. Ames, no, it won't be a whole holidays. It's only 10 hours, and I think most people watch it in double speed. Whoa! What happened there? I've lost camera. All right, technical difficulties. You guys can still hear me, eh? Okay, give me a second. I think my camera just fell apart. Where is it? Oh, man, it's gonna be one of these USB keys. I don't know which one it is. Let's see. Could be this one. Could be this one. I think we have problems everywhere. Alright guys, I think I've got to call it because my camera's just gone down completely. Unless, let me just check something. Hang on. Camera, Logitech. That's my kid's background. Where's my camera gone? Both are down. What is this? Not have happened that before. Logitech, Pixel. No. Alright team, look, I might actually just head off and try and fix my PC here. I don't know if you guys can hear me or not, but we'll catch you guys on next... When is it? Monday. I'll catch you Monday for level 3 differentiation. I gotta fix my computer. Ah, man. More work. Yeah. Catch you later, team. Have a good one.